Key to understanding a Mediterranean climate is very simple. Dry summers, wet winters. What causes that dry summer? It's because the subtropical high pressure moves over this area during the summertime. And so that subtropical high pressure, it migrates to the north during the American summer, but over time, in the winter, it starts to migrate back down. And as it migrates further back towards the equator, that subtropical high pressure, then this area is affected by mid-latitude cyclonic activity. So then you see a much different precipitation characteristic with a much wetter winter than you'd find during the high pressure that dominates in the summertime. Like I said, this is all due to the movement of those global pressure belts, which we're going to see illustrated in some graphics that follow. Where we're going to find this is on the southwest side of continents. So think about the southwest side of North America. You're going to find California, but also Mediterranean Europe. So Spain, Portugal, parts of France, Italy, and Greece are all good examples of a Mediterranean climate region. Further, we're going to find this also in southern Australia, and if you know anything about what these places all have in common, is they are all wine-producing areas, which I'll further explain on a following image. Finally, one of the things is another way to say the dry summers, but we have a summer drought. So this is going to play a key role in understanding the type of vegetation we would find here, because they're going to have to withstand the vegetation that summer dry period. Here we can see the Mediterranean climate region in yellow, which is on the southwest side of North America / United States, and then of course the humid subtropical climate region on the eastern coast. Now we quickly return to this previous graphic that we showed to explain how that subtropical high pressure moves over this area. So if you could think of this area being about 30 to 40 degrees north. So in this instance right here, they're just now being affected by the subtropical high pressure. But by December and January, you can see how all of this is shifted to the south. And so now, during the wintertime, 30 to 35 degrees north is underneath and affected by mid-latitude cyclonic activity. But of course, we go to June and July, we can see the subtropical high pressure moves considerably over this area and overwhelmingly dominates the characteristic weather pattern during the summertime. Another way to globally illustrate this is think about this as the winter pattern, and so here if you look over there on the left-hand side of the United States, you're going to find more of a mid-latitude cyclonic activity that dominates the area compared to the subtropical high pressure that moves over this area and brings quite dry characteristic weather. Now when we compare climate graphs for humid subtropical versus Mediterranean, you can clearly see that dry summer pattern, that dry summer characteristic weather that occurs in the Mediterranean climate region versus humid subtropical, which creates a situation during that summertime where a lot of that low-lying vegetation essentially turns brown or goes dormant. But with that being said, these are areas that have minimal amounts of cloud cover during the summertime. One of the things we'll talk about a little bit later on is human impact on the environment. How can we reduce our human impact on the environment? And I'm not going to shove solar panels down everyone's throat because it doesn't make sense for everyone. In an area like, in this case, Spain, or in southwest United States, you're going to get a considerable number of days during the summer with no cloud cover. So local solutions to local problems. Why not have more of a solar energy focus in this area of the country than what we would find in Indiana, where of course we have a much different summer characteristic weather pattern. Here we can see key characteristic also is the type of shrub. You're not going to see a lot of dense trees and forests in the Mediterranean climate region. Instead, you're going to find a lot more of this scrub, as it would be called, more low-lying, smaller trees and grasslands. Here we have the cork tree. The cork tree, actually, one of the things is the bark is that cork, which then goes into wine. Of course, a lot of cork has been manufactured and it's synthetic. It's fake cork. But the origins of cork actually come from this particular type of tree, which is found in a Mediterranean climate region. And so why has this tree evolved to have this cork type of bark? Well, same idea with why a cork is used in bottles, to help to store and to help keep things from penetrating that water or that wine, let's say. And so one of the things is this tree, it stores a lot of water in its trunk, and so that cork on the outside does a good job of preventing the loss of that moisture from inside that trunk. One of the things that is a problem here during the summertime is forest fires, and so it gets quite dry, the underlying surface. The grass obviously goes dormant, and so anytime if you get the occasional storm, whether it be convection or maybe occasional mid-latitude that sneaks down in this area, one of the things you'll notice is a lightning bolt can really kickstart, or even a cigarette butt can really do a good job of kickstarting these forest fires. Add to it a type of wind pattern called the Santa Ana winds, and you get yourself, this area is very vulnerable to forest fires, but also landslides in the wintertime when you get that all of a sudden that moisture that's been lacking throughout much of the summertime. When during the wintertime when they do get it, often what it does is because that surface is so dry, you get a lot of landslides during that first major rain event.